Okay, so this week in organic chemistry, you're going to be working with the NMR. This over here is the entire NMR section. It comes from this piece of equipment here all the way to the end over here, and this is the actual instrument that does all the computation. If you need to do any kind of work with this, and that includes printing all of your graphs or anything, all your spectra, you can do that from this computer, and it will print to the printer right there. If you decide to save anything on a USB, if you happen to take that graph off somewhere, and you bring one in, these USB ports on the front of this computer do not work, so you're going to have to stand over here, reach behind it, and get into the USB ports at the top and the back of the tower. So when you come in here, most likely the two programs that you'll use on the computer will already be open, but they are PNMR and NUTS. And so the one that is visible on the taskbar is the one that says AII, is PNMR. And if it's not already open, you can go ahead and open it like so. And it looks like this, has a graph in the background. You can go ahead and open up NUTS too, although I think that will open up automatically if you don't have it open to begin with. And I think if somebody has done one in the past, it'll automatically open up. But I'm going to go ahead and put that away. So once you've got those two ready to go, it should automatically be set up. Before, just in case anybody was doing any other types of measurements or anything, you need to check these diagnostics at the bottom. Most of the time, I think it should be calibrated when you start this, but all you need to verify is that this right there at the very bottom next to the taskbar says H1. That means you're doing a hydrogen NMR. And I think that's everything you need to look for at the moment. If I remember something, I'll say it again in a second. But once that's ready and you've already got it set to do hydrogen NMRs, you'll come over here to the actual top of the instrument and you'll open up this smoke-colored piece of glass like so. Now, stuff falls from the ceiling occasionally, so we try to keep this as closed as often as possible to keep stuff from getting in there because it's a very sensitive instrument, so you don't need to get stuff in there. So when it's time, you'll come over here, and this is what it looks like. This is the sample tube where the tube will go up and down to carry your sample into the actual magnet, and then you have the controls of the air to the left. It's this knob right here, and this is what you will use to control the instrument. That's really all you have to work with over here. So something always stays in the NMR. You never put something in there. Let me pull it out so you can actually see it. This is the component that controls the air pressure on the inside. Right now, the arrow is pointing, I guess if you were standing in front of the NMR, it'd be pointing at 12 o'clock. And if you're close enough to hear it, you'll hear it when you're here in person. I don't know if you can hear it through the iPad, but it's hissing a little bit. That's air on the inside that's causing the tube to spin on the inside of, this is causing the spindle to spin. So to stop it spinning, I turn it to the 3 o'clock and let it stop. And then once that's done, I slowly turn it to the 6 o'clock, and that will send air up through the chute to carry the spindle to the top. If you do it really fast, it'll shoot out of the top. I don't think it will go that far, but it's better to just do it the slow way to make sure nothing happens here. Now, this is spinning pretty fast. It won't burn your fingers if you grab it, but take a chem wipe and go ahead and pull the system out. Sometimes I just like to turn the air pressure down a little bit because it's kind of bothersome. But this is what it looks like. So your sample is on the inside of a borosilicate tube. This is closed. This is our reference sample. You'll most likely be preparing your own. So if you're preparing your own, you'll come right here to underneath the computer, and all of the tubes and caps are in this top drawer. They say borosilicate deuterotubes. They come in packages like this. You can just pull one right out of there, and then a cap to go on top of it. When you're actually filling one of these, you don't need to fill the tube all the way to the top. I've got a sample of, I think it's ethyl benzene over to the sides where we're going to be performing the NMR on. You don't need much in the tube. You'll only need about, let's see if I can set that there without it touching anything. Good. You only need about 2 fingers worth of sample inside. So this actually may be a little much, but this is about all you need. You don't need any more than this. That right there will have enough in the tube to get you a strong reading out of the NMR. But, so, when we're working with this, the biggest thing you need to worry about is you don't want to touch this plastic spindle with your fingers. It'll get oil on it and mess it up. So what you need to do is you need to pull a chem wipe and just grab it on the sides and slide it off the tube. Not hard, pretty easy to do. Just don't pull it too hard. If you're expecting something big, it's not that bad. And when you're done, pull the one you want to put into the NMR and just slide it just enough to see the bottom of it pointing out of the spindle. You don't have to worry about how far it actually needs to go up because that's what this hole right here is for. You just take this, put it in, push it down until it stops, and it's ready to go. That's all you have to do. So now, if you're worried that you will forget, because it may be quick to forget that there is air running or there's supposed to be air running, just leave it on, because when you've done this a couple of times, it won't take you very long to switch out samples. But with the air back on, I'll take this back down, set it right there under the current, and it will float again. Now, You will most likely mark the top of your tube with something to let you know what's in the tube. In this case, it's marked with E, ethylbenzene. So that way you can actually see the next part. Turn the air back down slowly to set it back down into the NMR. And then when it's down in the bottom, turn the dial back to 12 o'clock, going counterclockwise. Now, at this point, you'd probably need to grab a flashlight or something to look down into the tube. You need to verify that the tube itself is spinning, and that's why I said it'd be good to mark the top of it if you haven't already. If you look on the inside, it may be hard to see on the video, but it is spinning rapidly on the inside, verifies that it's doing exactly what it's supposed to do. It's ready to be taken, sample's ready to be taken. The measurement is ready to be taken, excuse me. So, with that in place, now you can come back to the computer and start working here. The first thing you need to do is you need to shim the instrument. All of these codes and the actual order of this will be on this page that's off to the side. It says Quick H1 NMR, and it has all these codes listed to the side. It's in bold. It'll tell you what you're supposed to do. It says type shim and then enter, S-H-I-M, shim, and then enter. I'm not going to do that because it takes a minute, and I did it like 5 minutes ago, so it's still okay to go. So, once this is all done, it's ready to go. The relaxation delay is all fixed. Now, the next thing you're going to need to do is you need to tell it how many times it needs to run the sample. It needs to take that NMR for it. And so you can do this by changing the number of scans over here. Currently, it's set to 1. That's not very good. You need to have more than that to actually get a strong reading off of this stuff. So this right here is the letter code that you plug into it to actually pull up the screen to calibrate it. So number of scans is NS, so I hit NS and enter, and it pops up how many scans do you want it to run. And so I'm going to go ahead and say, let's just do 4, because I want it to be pretty fast for the purpose of this video. Dr. Hamilton may tell you to do 8 or 16. They're always going to be multiples of 4, so you can either do that. I'm going to choose 4. So now, after I do that, the number has now changed to 4. It will run the cycle 4 times, and then it will alert me whenever it is finished. Okay, now that I'm done with this, all I have to do now is type ZG, means 0, go, and then it will ask me to save it somewhere. You can save it wherever you want to. I'm just going to hit this because it's a temporary file, and then it will run on its own and complete the scans. In a moment, you'll see that information is poured onto the screen. You don't have to worry too much about this info up here. You just want to verify that this number at NS is going up, 104. It's working fine at the moment. In the meantime, it'll be done momentarily. I'm going to go back over to nuts, and we're going to take a look at all of the pieces here. So as of right now, there's nothing on the screen because I don't have an NMR to import into it yet, so we can look at it. But it'll look something like this. So eventually we'll see a signal whenever this finishes in a moment. This window will disappear. That's how I know whenever it's done. We have various tools up here at the top that will aid in developing and interpreting the information that the NMR returns to you. And you can also find the standard stuff, file, save, print, etc., the stuff that you've seen everywhere else. Okay, so now this is completed. It said 4 scans completed. I'm back on nuts. Now to import the last NMR that has been run, I type A2, and it will automatically import the information into the window. So you can see what we have here. Looks pretty decent. The only thing that we need to do now is this is not aligned with the TMS signal. You probably read about this, or you will hear about it eventually. You need to align it to a TMS to get a reference between all of the actual signals and where they are along the spectrum. If we were to do this, all we would do is we'd identify where the TMS signal is, and you can have one of us come and help you or ask Dr. Hamilton. We'll find one of the peaks over here in this region. Notice that it's less than 0. We want that peak to be at 0. So let's pick this furthest one right there. I click on the screen, I left click, and it will pull up all of this information that I have at the cursor. In this case, it tells me that I'm hovering over negative 1.7 parts per million. So that's what I need to adjust the field offset to. So I need to remember that number, write it down somewhere, it doesn't really matter. And then we'd run back over here, and we type FO, field offset, and then it'll tell us where's the current position of reference. I need to tell it it's at negative 1.7, that's where it was. And now I want to tell it where to go. I need to take it from where and move it to where. I want to put it at 0. Now, in this case, I would run the NMR again. It would take the exact same thing and it'd just shift it downfield. It'd rerun it, but there's no point in sitting here waiting for it to come back up. We'll just use what we have here. Okay, the tools up here, you can integrate underneath the peaks. You can move it up and down the spectrum. You can zoom into certain portions, and we'll go over each little part here. If you look along the top, we're not going to use all of these you'll use the zoom feature, and you'll use the phasing, and you'll also use the integration. The first thing you're probably going to want to do is you need to hover over mouse phase. It's the one that says PH, and you can hover your mouse over each one of these and it'll tell you what it is. The phasing is basically, it looks like you're rotating a tumbler, and it will take the signals and rotate them around. So you can see, as I do this, you can see that it's rotating it around. We need to try and make it as flat as possible, so you just kind of rotate it until everything looks pretty decently aligned, and then that's enough. Once that's done, click it again, and it will take you out of the phase, or it should. Let's see if it's still done. No, it won't. Maybe we can do it. Each one has a different method of escaping what they want, so it's kind of hard to do. If that doesn't work, you can... Not sure why it's not letting you out. It did a minute ago. Anything to add?
If you do the zoom function and then just circle over everything, like don't like actually zoom into anything, like select the whole screen, it'll let you out.
There you go. See, sometimes it lets you do that normally, but it doesn't. I know for a fact that zoom offset is kind of finicky. If you see the cursor right there, it says ZO on the underside. It will not close automatically, and you'll have to go up here and exit it yourself. And so, as it turns out, that choosing the zoom offset can actually help alleviate other problems as well. It's not the most, what's a good word? It's not the most, yeah, I'm not gonna do that because I'm on video. What I'll do in its place is, I don't want anybody to hold that against me. So we already looked at the mouse phase and we put everything flat. What we can do next is we can hit peak pick, that's the furthest one in this group of 5, and it will select the ones that have the parts per million that we're concerned about the most. You'll see that they come up here to the top of the screen. Normally this would have already been shifted off to the side, and then each one of these would be of significance, but you will have that on your corrected one because you would have already field offset this if you were doing this yourself. The last thing you need to concern yourself with is automatic integration. This computer is pretty smart. It will generally try to integrate out of the peaks it thinks are important, and it will display the information off to the side. So after you hit relative integration, you see that these lines appear in certain positions. These lines delineate where it starts integrating and ends integrating, and then it displays the area underneath the curve. So this right here, it hasn't been calibrated yet. It says there's 2.5, 2.53 equivalent hydrogens. We'll mess around with that in a minute. And then over here, it starts integrating from here to there and says that this is 1 equivalent hydrogen. But notice over here that this one was not integrated yet. For some reason, it didn't recognize that one, so you're going to have to go in and add that one yourself. If you go up to, I have to go find it. There it is. Let's see that myself. Well, there it is. I picked the wrong one. Sorry. If you go into that list and go down to integrate display, not automatic integration, I picked the wrong one. Integrate display will allow you to modify and then add your own integrations onto the NMR spectrum. So we have 1 and 2 here that I think are fine. The last one I want to add is over here. I'll click first to add the first marking, and you see you have to click twice for some reason, and then it will appear, and then you drag your mouse to the other end and it will integrate the area in between the two. So if I do this, say I want to capture those 4 peaks there, I'll do that and it comes up 1.52 is the relative integration for that. So all we have here now is you have each one of the peaks of interest that have been integrated. The only thing left to do is, if you can, is to bring everything up to where everything is a solid number. In this case, it's actually a fairly good NMR because each one of these can be multiplied by 2 and you'll get a relatively even number. This would be 5, this would be 2, and that would be 3. It doesn't display it in the menu, so if I can try to remember how to do this, I wonder if you can. Let's zoom offset. Okay. They also had everything in here that you can imagine is in this book over here to the side. It's in between the tower and the other tower. And if you're looking for a particular code of some sort, you can look through here or ask one of us if we happen to know what it is, and you can find the codes that you will need to do it. So they've got everything here. You just have to look in the right, I think there's an index actually, if you look in the right place, or a table of contents. And so it can tell you exactly where you need to go to figure out what code you need to add in here. So I would look under integration, which is on page 11, which should tell me how to bring everything up to the next common multiple. Let's see if I can find it. All right. Let's see. That or here too. Go back to process and pick integrate display again. Let's see if I hover over this right there and hit V. Maybe I double click it. Maybe hit V. Maybe not. We'll see. Let's see. So we go back to integrate display, and then select one. So, V maybe. Go low. Well, it's not cooperating. I know that we can click on one and hit delete to get one to disappear, but I wonder if we can click on one and get it to, there we go. All right, so its current relative value tells you that it's 1. We want to up that, again, like we said a minute ago, that we need to multiply everything by 2. And the cool thing is, if you change one of them, it will automatically change everything else. So this one had a pretty good baseline standard. It was 1 exactly, but now it's 1.02 because I changed the integral. If we just hit 2 in its place, it will change that number and multiply everything else by the amount that it took to change it from 1.02 to 2. And so in doing so, it goes from 2 under this graph to almost 5, 4.97, and then 3 under here. So now we have relatively clean integrations. And so once you're done with this, if you have to find any other codes, unless you don't have to do anything else from here, you can print the screen, which in this case, I'm more interested in this area here, so I'll use the zoom offset tool to zoom in. If I click the right button. And so now everything I have that's of interest is now on the page. I can see all the individual peaks on here. I can see all the integrations. And now I can either save a snapshot of this if I wanted to do, this is Windows 7, so I probably won't do that. I can go to snipping tool, and I can create a new, and then I can pull everything of interest in here. Be a little more careful with how you do it. I'm just doing this very quickly. And then you can see everything that's of interest on this graph, and you can save it wherever you want, wherever you need to save it, onto USB. If you need to save something, you have to bring a USB or some other storage device, because it's just like the IR, it's not connected to the internet. So you'll have to do that. Alternatively, you can just hit save, and then it will tell you, you can find a place to put it if you want to add it somewhere or create a folder. Dr. Hamilton will tell you exactly what can be done with these, but that's about all you have to do with that. And then once you're done with this, all you have to do is close it out. There's nothing left to be done. So this system, as you've probably seen already, is a little finicky. So if this is on and people have been running NMRs already, it would probably do you good to close everything out and then reopen it again. Because sometimes it'll kind of like, I don't know what happens on the inside, but sometimes it'll like compound on itself, and then it doesn't like to run anything anymore, or it'll run the wrong program. So if you run into any problems, it's probably a shimming problem, or it's probably some kind of like internal thing that would just be fixed by closing everything off and then reloading it and then redoing your NMR. When you're finished, come back over here, still spinning on the inside, turn it to 3 o'clock to turn the air off, and then up to the top, chem wipe, out. You can hold the silicate glass with your hand, that doesn't really matter, but I need to take the chem wipe to hold the other piece, and put whatever is supposed to go back in there, in this case the reference, back onto the spindle, get it to the right position, back down into the tube, and then close the top. And that's about all there is for running the NMR for Organic Lab. If I forgot anything, it will be told to you eventually, because we'll know tomorrow.